I am Emmanuel de Failly, working at LIST, and I started working here in 2014. So we are working, generally speaking, on what we call coupled materials. So those are materials that are able to transform one kind of energy in another one. And more specifically, at the moment, we are working on new ways to cool. So we are using specific materials to cool down, and the interest of those materials that we are not using greenhouse gases, which is the case in our fridges. And second thing, we could do it more efficiently. So meaning that the principle we are using could enable to use less electricity than what we are currently using. So more efficient without greenhouse gases. And the other topic is, which is the reverse topic in terms of physics. We are trying to recycle or reuse the waste heat that we have and transform this waste heat in electricity. And we have materials that are able to do this, so this is why we call them smart materials. Probably the most prominent one is related to my recent ERC grant, which is stemming from this waste heat recovery that we transform in electricity. So I'm very happy that the way it worked was an idea that I had during my PhD, so a long time ago, and I could put this in place thanks to FNR, partly because I had a project on the topic at the time. The project was called Thermodimat, and thanks to it, so we had a big paper in 2022 that showed that we found new materials that are able to harvest and transform much more waste heat than we thought before. And then recently I got this ERC that will give me the possibility to push further the concepts that we had in mind for some of this. Now I think I have the opportunity with this grant, and I've got also several grants that are related to these topics. So waste heat, energy recovery, and efficient cooling. So now I'm in a position where I can really push the concepts at higher maturity level. And then the two questions that I really want to answer on these two topics, waste heat and efficient cooling, is how can we scale this up? So is it possible? Because it's good to see that we have now materials that are able to do great things, but we have to scale them up and find that there are still things that we have to unlock to check that it's okay. What are the best materials? Are there industrial ways that are not too cumbersome to implement the scale-up? And the second question, which is very key, and that still there are scientific parts that are still to be investigated. This is about efficiency. So this efficiency concept is really at the heart of these technologies, and which is essentially how much energy you have to put in to get something out. So in the case of waste heat, so we have to add some thermal heat. How much of this thermal heat can be transformed in electricity? So this is the efficiency. And when it comes to cooling, this is how much do we have to put in electricity to get a certain cooling power. So these questions are still very strongly related to materials properties, and this is what I want to investigate in the years to come.